So this video we are going to begin Unit 5. Unit 5 is all about exponents and exponential functions. So we are going to start with day 1. So if you would get to your day 1. So day 1 is learning about zero and negative exponents. So this entire unit is all about ways to reduce down and simplify problems containing exponents. And there are many rules and shortcuts, but they're all based on patterns. So you don't have to memorize anything if you want to work things out with the pattern. And so I'll explain that in a minute. All right, you're going to need a calculator. So if you don't have a scientific calculator, I would make sure you're able to get one like from Walmart or Target. You can get them for like 10 bucks. They're not that expensive, but they're definitely going to help you as you're working. Okay, one important thing here is we are going to avoid decimals this unit. Now, sometime when we get to exponential growth and decay, we'll work with decimals. But whenever we are evaluating or writing things out, we're going to leave them in fractions or whole numbers. Whole numbers are great. So 1, 2, and 3, I just want to review and talk about how to evaluate these types of problems. So 5 to the 4th power. So I just want to remind you that when you have an exponent here, it's not telling you to multiply 5 times 4. It's telling us that there are 4 5s. Okay, and so let me give you a little bit of vocabulary here for just a minute. So the 4 is the exponent. Okay, and the 5 is considered the base. So the way this is set up is I'm taking the base and multiplying by itself the number of exponents. So if I were to expand this out, this is really 5 times 5 times 5 times 5. You can certainly type that into your calculator. Now, most scientific calculators have a key that look like that little caret key. So if you were to type it in, you would type the base in first, the 5, and then the exponent key, and then the 4. Okay, so whatever you have on your calculator, if you want to multiply the 4 5s, if you want to do 5 to the 4th, we get 625. Okay, now when you're in class, if you want me to look at your calculator, please ask those questions because it's a great tool and you want to be able to know how to use it. All right, example 2, 32.5 to the 1st. Okay. Now, I'm going to break my no decimal rule here. Since I'm starting with a decimal, I can end with a decimal. For the most part, we're going to have fractions. But the reason I have this problem in here is, I want you just to recognize that when you raise something to the 1st power, it's just itself. And so we often don't write the power 1 in our problems, even though it exists there next to the number. Okay, number 3. I have 3 sets of negative 2/5. So I'm going to take negative 2/5 multiplied by a second negative 2/5 multiplied by a third. So let's just multiply across the top. Negative 2 times negative 2 is 4. 4 times negative 2 is negative 8. 5 times 5 is 25. 25 times 5 is 125. So our last one here is negative 8 over 125. So this is a better example of no decimals. We just want to leave it as that fraction. Okay, let's talk about zero exponents. So any non-zero number to the 0 power is 1. So let me just go through these 3 and then let's talk about why. 3 to the 0. Now if you want to type that in your calculator, go ahead. You're going to get 1. Negative 4 to the 0, you're going to get 1. So generalizing, any variable to the 0 is 1. Okay, and let me show you why real quick in a pattern. Let's say we take 3 to the 2nd power, which is 3 times 3, which is 9. Now let's reduce it to 3 to the 1st power. Well, 3 to the 1st is 3. Then 3 to the 0. So if you go from 9 to 3, what we did was we divided by 3. So extending that pattern to go here, I'm going to divide by 3 again. And 3 divided by 3 is going to be 1. So you're always going to have that base divided by itself. Okay, you can type in 1,000,000 into your calculator, raise it to the 0 power, you will get 1. So that's where this comes from. Any non-zero number to the 0 power is 1. Now I want to talk about the middle example. I want to talk about the difference between what's on your paper and what if I took the parentheses away. If I take the parentheses away, this is really saying -1 times 4 to the 0 power. And so the answer to this one is -1, not +1. So the parentheses are super important. This is saying 0 is to the entire number -4, whereas my second example here is just 0 is going with the +4, and then there's a -1 there in front. Okay, we will see that come up a lot this unit, and I will try to talk about it every time. Okay, second one. Negative exponents. So I've got 2 examples here. So my first example, I have any number a raised to the negative power. Let's say n is any number. So the way we're going to do this is, let me give you the rule and I'll talk about why. So the answer, a to the -1 power. Now remember, we're trying to rewrite this with positive exponents. So let me put a little note here. Rewrite with positive exponents. So the way we do this is we do the reciprocal. So if I write that as a fraction, the reciprocal is flipping it over. So when I do the reciprocal, what happens is it will turn the power positive. Okay. Same thing on the second one over here. Do the reciprocal. When you flip it over, it makes the power positive, which then this just becomes a to the n. Okay, reciprocal. Now, I'm going to actually use my example up here. The reason that is, let's continue this to 3 to the -1, 3 to the -2. So if I do that same property, I divide by 3. If I take 1 and divide it by 3, I get 1 over 3. Which is the same as 1 over 3 to the first. So see how it's just the reciprocal and the power is now positive. So let's divide by 3. So if I divide by 3, I actually get 1 over 9. And another way to write 1 over 9 is 1 over 3 squared. So you evaluate it by keeping, and because we don't want decimals, if I type this into my calculator, I most likely will get a decimal. So we evaluate by taking the reciprocal and making the power positive. Okay, let's run through some answers here. Let's evaluate. Let's keep them as fractions if we need to. All right, 1/5 to the 0. Anything to the 0 power is 1. 2 to the 0. Anything to the 0 power is 1. -2 to the 0. So it's the entire number to the 0, gonna be 1. Number 7. So this is really, so this part is going to be a 1. So the answer is actually going to be -1 because the negative is not inside the parentheses. Okay, example 8. We're going to do the reciprocal. So the reciprocal will be 1 over 2. And remember, when you do the reciprocal, it changes the power. Now let's go ahead and raise 2 to the 5th. Okay, so I'm going to use my calculator. 2 raised to the 5th is 32. So this would be simplified as 1 over 32. Again, don't turn that into a decimal. You want to leave it as a fraction. Okay, now number 9 is a little tricky because I only want to take the reciprocal of the part of the problem with the negative power. So 3 to the -2 has the negative power. 2 has a positive power. It's 2 to the 1. So here's how I want you to separate this problem out. So this is really 2 to the 1st over 1 times 1 over 3 to the -2nd. So I only do the reciprocal of the one that has the negative power. So 2 is going to stay, okay? So I'm going to leave that as 2, and I'll put a multiplication sign. Do the reciprocal of the second fraction. So that will now read 3 to the second. And so now if I do order of operations, 3 to the second is 9. Bring down times 2. 2 times 9 is 18. So the simplified answer to this problem is going to be 18. Okay, so the main difference between number 9 and the examples above is it had a 1 underneath it or a 1 above it. So like, see how I have a 1 above it, so I could flip the whole thing over. I had a 1 beneath it here, so I could flip the whole thing over. So when I don't have just a 1, I need to really separate that problem out. Okay, numbers 10 and 11. So what I want you to see is I have all of this to the negative power. So I'm going to take the reciprocal of it. So because it's already a fraction, when I take the reciprocal of it, and since it's in parentheses, I want the whole thing to be the reciprocal, I'm going to flip over the entire fraction, and when I do that, the power will now become a positive 2. And so now I can look at this and I can say, okay, this is 3 to the 3/5 times another one because it's power 2. And then when I multiply across the top and bottom, I get 9 over 25. And 9 over 25 will not reduce down, or else I would reduce it down, but that's as far as it can go. Same thing on 11. I see an entire fraction to the negative power. So let's take the reciprocal of the whole thing and make the power positive. So now separate it out or expand it out. 4/3 times 4/3 times 4/3. So 4 times 4 times 4, or 4 to the third, is 64. So I have 64 over 3 times 3 times 3 is 27. Okay. So that's really that first page there. So all of those examples just gave you a little bit of the various types of exponents. Let's keep going. Let's do a little bit more. We're going to bring a couple of concepts together. Rewrite the powers using positive exponents, and let's simplify. All right, so what I see here is the negative power is only in the numerator. Okay, so remember, you can break out this problem. So I can write this as 1 over 5 times a to the negative second over 1. Okay, all I'm doing is separating it out so I can isolate the negative power. Let's flip over the negative power. So I've got 1 over 5. Flip the second one over, 1 over a, and when you do that, it becomes positive. Now multiply it back together. So 1 times 1 is going to be a 1. And then it'll say 5a squared. Okay? Now, one other way to look at this, let me go back to the top. A to the negative second over 5. So one other way to do this is to say, all right, the only thing I'm taking the reciprocal of is the numerator. And so if I take the reciprocal of the numerator and nothing is left up there, there's really just a 1. And so then what's left on the bottom is the 5. We never moved it. And then the a squared came down. Okay, that's another way you can look at it once you get a little bit more proficient with working with these powers. But if you don't know why you're doing that, you're very likely to forget what to do. At any time, you are welcome to pause the video. In fact, you might pause it now and give yourself a few to practice on your own. And then come back to the video, and if you have a difference than I do, see if my explanation helps. Okay, number 13. So here's what I'm going to propose on 13. These are all being separated by multiplication, right? Would you agree with that? Everything's together. So I'm going to separate this problem out as 6 over 1 times a to the negative third over 1 times b squared over 1 times c to the negative second over 1. Okay, I'm going to write all 4 of those as separate fractions. So the reason I did that, negative exponent, negative exponent. So what that means is those are the only 2 that flip over. So I've got 6 over 1, flip over the second one, 1 over a, and remember, when you do that, you can make the power positive. Don't touch the second one, b squared over 1. Take the reciprocal of the last one, 1 over c squared. Now bring it all together. So I've got 6 times 1 times b squared times 1. So that is just going to be 6b squared. Multiply across the bottom, and I've got a to the third times c squared. So I just write them right next to each other. A to the third c squared. Okay, and that is our solution. Okay, number 14. Now, if you want to leave 14, you can kind of go like this. You can say 3 over 1 times x over 1 times y squared over 1. This is the only one with the negative power, so it will be reciprocal down to the bottom. So 3 and x do not move. When you flip over y to the negative second, you get y to the positive second landing in the bottom. So 3x over y squared. Okay, number 15. Negative 5 over 1, x to the negative second over 1. Now, negative 5 is negative 5. It is not a negative power, so leave it alone. I do need to do the reciprocal of the second part. So I'm going to leave negative 5 where it is, flip over x to the negative second, and so it becomes negative 5 over x squared. You also could just, sometimes you'll see the negative out in front of it like this, not necessarily attached to the 5. It really, a lot of times we just pull it to the numerator, but it's equivalent. Okay, 16. I see all of that to the negative second power. So I'm going to flip it over, 1 over, I'm going to leave the parentheses there, make the power positive, and now do the math. Negative 3 to the second. Negative 3 times negative 3 is positive 9. So positive 1/9 is our solution. Okay, if you have questions on zero negative exponents,